Hey guys, we're going to take some notes over a real easy concept today, and that's just how to graph an exponential function. These are your basic parent graphs. What I mean by parent graphs is these are going to be the ones that you're going to see just like the parabola before any transformations are made to it, before it's moved up, down, left, right, stretched, shrunk, or reflected. But remember, I told you that you're going to need to remember all of the transformations because those same things are going to happen to this. Okay, so one thing real quick you're going to need to know is that this is always going to be referred to as your base. Your base is just going to be a number. Up here, this is always going to, of course, be your exponent. And for these, they're always going to be a variable because we're going to be plugging in a number to that. If there's a number out here, that's something that we're multiplying by. So this ends up being like a vertical transformation, a stretch, a shrink, and of course if it's negative, it would end up being a reflection. But we'll talk about that more tomorrow when I get back in class. So today we're just going to take notes over these three things real quick. Shouldn't take long. So on the first one, if you were to plug these things into this equation, it's kind of like the last page of notes that we took on page let's see, page 8, whenever we were filling in the exponent table. So let's start with some of the easy part. If I did 2 to the 0 power, and I'm just going to kind of write that out, 2 to the 0 power, we talked about how anything to the 0 power was 1. Okay, 2 to the first power, so I'm plugging in 1 into the exponent. 2 to the first power would be 2, and 2 to the second, or 2 squared, would be 4. When you go into the negatives, it is pretty much the same thing. It starts kind of repeating. So what happens, except for it doesn't exactly repeat, what happens is it ends up being 2 to the negative 1, which means it flips. So it becomes 1/2. And 2 to the negative 2 would also flip and become 1/4. So the negative exponents flip. Right, and then we want to graph this, and it can be a little bit of a mess. It seems like it, but guys, you know what fractions look like and partial pieces. You know what happens if you have a square and you were to cut it in half, or if you wanted to find a fourth of that square, then you would cut it into 4 pieces. Okay, so let's see here. So if you had another square, and you'd have 1, 2, put 3 lines in it, and so like 1/4 would be there, 1/2 would be there, 3/4 would be there. So that's what we're gonna do now. So if I plugged in 0, I got 1, so the point 0, 1. I plug in 1, I get 2, so the point 1, 2. Plug in 2, I get 4, so the point 2, 4. Okay, and then go the other direction. Negative 1 is 1/2, so right in the middle of my box. Negative 2 is 1/4, so it's just right above the x-axis. It ain't gotta be beautiful, okay? And then you're gonna connect these, and this graph is gonna curve like this. And notice those were getting smaller and smaller. They're actually not gonna get smaller than 0, so you don't wanna cross over the x-axis. Okay, so that's the first one. We do the exact same thing with 3. So 3 to the 0 power is 1. 3 to the first power is 3. 3 squared would be 9. 3 to the negative 1 would flip, so it's going to be 1/3. And 3 to the negative 2 would flip, it'd become 1/9. And so those are going to be a little more rough. It's okay. I'm not looking for perfect whenever you graph those points. I just want to see that it's in between the right things and that it kind of is decreasing, basically. All right, so starting with 0, because that's always the easiest. 0, 1. Plug in 1, I get 3. Plug in 2, I got 9. Okay, and then going backwards, Plug in -1, I get 1/3, which is a little less than 1/2. Or not, yeah, a little less than 1/2. Let me check my math. And then -2, 1/9. So I just put that basically just a little bit above the x-axis. And again, connect curve towards the x-axis, just don't cross over it. Okay, next one, 1/2. So things get a little confusing here. Hopefully not too bad. Here we go. If I plug in 0, well, if I plug in 0 to anything, we talked about that, you just get 1. 1/2 to the first power would just be 1/2. And 1/2 squared, you're just squaring both pieces. So 1 squared is 1 and 2 squared is 4. Now keep in mind what we said. That means that you take your answer before you apply the negative and you would flip it. So 1/2 to the first power would be 1/2. But when you flip it, it becomes 2. And 1/2 to the -2, that would be 1/4. And then you flip it so it becomes 4. Hope you got that, guys. All right, let's see here. Let's graph this. So starting at 0, 0 is 1. And then 1 is 1/2. And 2 is 1/4. And at -1, I have 2. And at -2, I have 4. And again, just connect. All right, and just to give you a little more info real quick, these are what we call decay graphs. And these are called growth. Exponential, well, technically exponential decay and exponential growth. All right, let's answer this kind of question down here. It leads us into something we'll do later. I kind of wanted to do it next, but we need to go all into the graphing before we start doing some solving of these things. But it says solve 2 to the x power. When does x to some power equal 8? And it tells you to look up at number 1. And when would it equal 8? Well, let's see here. Let's play a little bit of guessing game. 2 to the first is 2. 2 to the second is 4, and 2 to the third would be 8. So you're kind of thinking about 2 to what power is the real question. So when you see these kind of things, you ask 2 to what power gives me 8? And I've now found that answer, and the answer is 3. So x would equal 3. Whoops, sorry guys. And so x would equal 3. All right, and that's it for your notes. You can work on IXL. Thanks, guys.